Today, we're going to break down one of the most overhyped, misunderstood, and yet powerful technologies of our time, machine learning. I know it all sounds very futuristic. Machines actually learning? How is that even possible? Here's the truth. Machine learning is no magic. It's math. It's patterns, it's algorithms processing data to make predictions or decisions. And once you get what's going on under the hood, the whole concept becomes way less intimidating and way more empowering. So if you've ever nodded along in meetings or podcasts without really understanding what machine learning is, this episode is for you. Welcome to Tech Anatomy. So what is machine learning? Let's start with the basics. Machine learning is a way to teach computers how to recognize patterns in data. Think of it like this. Instead of telling the computer exactly what to do in every situation, we give it examples. Take, for instance, a big list of house prices, along with details like square footage, number of bedrooms, and location. That's your input, your database that you will be feeding to the machine. It's like giving it a worksheet where every question already has the right answer written next to it. Over time, the computer starts to notice patterns. In this example, it might learn that bigger houses in certain neighborhoods tend to cost more. These patterns are what the model learns to recognize. From there, it can take a look at a new house, one that it's never seen before, and make a pretty good guess about its price. It's like learning through examples, not instructions. This is already how we learn as humans. Imagine teaching a child how to recognize a cat. You would show that child pictures of cats, and eventually, even if they see a cat that they've never seen before, they can say that's a cat. How? Because they've learned the patterns: fur, whiskers, ears, tail, etc. Machine learning is the same process, but with math and data instead of neurons and experience. Now, how do machines learn? Let's walk through the main steps of how machines learn. I'll use a healthcare example, predicting whether a patient has diabetes. Step 1, you collect the data. You need data to learn from. In our case, maybe we have patient records, age, weight, blood sugar levels, family history, and whether they were diagnosed with diabetes or not. Think of this as your training material. Very concretely, imagine a spreadsheet where each row is a patient and the columns include things like their age, weight, and blood sugar levels. These are your inputs. Then there's one last column showing whether the patient has diabetes. That is your output. The goal of the machine is to learn how the inputs relate to the output, so it can guess the right diagnosis for new patients based on the same kind of input data. Step 2, pre-process the data. This is cleaning the data, making sure the info is accurate, consistent, and formatted correctly. Missing values, fix them. Different units, standardize them. Typos, correct them. Just like you wouldn't study from a messy, disorganized textbook, a model cannot learn from bad data. And this step is often much harder than it sounds, because in real life, data is very rarely clean. Databases are often full of inconsistencies, missing values, weird formats, and errors. It can take a huge amount of time and human effort to sort, fix, and structure the data so it's usable. In fact, many data scientists spend most of their time just cleaning data before any learning can even begin. Step 3, choose a model. This is where the math comes in. A model is a mathematical function. There are many types: decision trees, linear regression, neural networks. You pick one that suits the task. Let's take a super simple example. Say you want to predict the price of a house based on its surface area. You gather lots of examples, houses with different sizes and their prices. You realize there's a pattern. Bigger houses usually cost more, and the price increases at a steady rate. On a graph, this looks like a straight line. In math, we call that a linear function, often written as y equals wx plus b, where x is the size of the house and y is the price. The function, that straight line that we just described, is your model. Of course, this is a very simple case, but it shows the idea. Finding the model means finding the formula that best fits your data so you can make new predictions. In the diabetes example, it's the same idea. Choosing a model means finding a formula that, when given the blood sugar, age, and weight of a person, can give you a probability for the person to develop diabetes. If this is the first time you encounter this explanation, do not worry if it still feels a little bit complicated. That means that you're learning something new. Rewind the episode and have another listen or two until it starts to make more sense. You can even take a piece of paper and draw what you're hearing so that you can represent visually everything you hear on this episode. Moving on to step 4, train the model. Here's where the learning happens. At this step, we use the data we've collected to help the model fine-tune its formula. Imagine you start with a basic math formula, a rough guess that tries to link input like age, weight, and blood sugar to whether someone will develop diabetes. This first formula is very generic, and when we apply it to the data, the prediction will often be wrong. So what happens next? The model looks at how far off its prediction was from the real answer in the database. This gap is called the error. It then tweaks the formula to try and reduce that error, bit by bit. Think of it like adjusting the knobs on a radio to get a clearer signal. Each time the model sees the prediction was too high or too low, it updates the formula to be a little bit more accurate the next time. This cycle of adjusting the formula to reduce the error is repeated over and over, thousands or even millions of times. Eventually, the formula gets so good it can make fairly accurate predictions on new data it hasn't seen before. That's how the model learns, not by memorizing, but by improving a math formula until it works well. Step 5. Test the model. Once your model seems to have learned well from the training data, it's time to give it a test, but not with the same examples it has learned from. You need to check how well it performs on new data, cases it has never seen before. This is called the test set. Think of it like giving a student a final exam after they've studied with a practice book. The test checks whether they truly understood the material or just memorized the answers. If the model gets most predictions right on this fresh data, it means it has genuinely learned the patterns. If not, it may have overfitted, which means it memorized the training examples too closely and struggles with anything new. In that case, you'd go back, adjust the model, maybe give it better training data, and try again. This step is crucial to make sure your model isn't just smart in theory, but useful in practice. So that's it. That is machine learning. Data in, pattern, prediction out. Thank you for listening to part 1 of our 2-part series dedicated to understanding machine learning. We will see you soon for part 2, where we dig into the use cases in healthcare and explain how they work under the hood. See you soon.